welcome back. I'm Laila again. Today, I'm gonna tell you about really interesting topic. It's output devices and how modern GPUs drive high-resolution displays. First of all, what is a GPU? It's the graphics processing unit, which has become one of the most important types of computing technology, both for personal and business computing. But what does a GPU do? GPUs were originally designed to accelerate the rendering of 3D graphics, create more interesting visual effects and realistic scenes with advanced lighting and shadowing techniques. Other developers also began to tap the power of GPUs to dramatically accelerate additional workloads in high performance computing, HPC, deep learning, and more. Now, let's talk about the start of GPU. The first hardware T&L GPU on home video game consoles was the Nintendo 64's Reality Coprocessor, released in 1996. In 1997, Mitsubishi released the 3D Pro per 2MP, a GPU capable of transformation and lighting for workstations and Windows NT desktops. ATI used it for its Fire GL 4000 graphics card released in 1997. Now, what are GPUs used for? Gaming, machine learning, 3D graphics rendering or video editing, scientific computing, computer simulation, artificial intelligence, computational finance, edge, memory, bandwidth, and blockchains and cryptocurrency mining. Now let's talk about some of them. First, video editing. With a GPU, video encoding can be done relatively quickly without overburdening system resources. It's important to note that encoding high-resolution video can still take some time to complete even with a high-powered GPU at your disposal. With video formats supporting higher and higher resolutions, an adequate GPU is an essential tool for the modern video editor. Also, let's talk about 3D graphics rendering. Modern film studios often depend on GPU technology to generate ever increasingly lifelike and dynamic computer images, making the hardware a vital part of the movie making process. Digital artists employ GPU enabled computers to create abstract displays that couldn't be created in physical space, allowing them to create works of art unlike anything seen before. With a proper combination of hardware performance and artistic vision, GPUs can be a powerful creative resources for any media operation. Machine learning. Machine learning involves systems that use data to learn, identify patterns, and make decisions independent from human input. This analysis is performed by software known as machine learning algorithms. The resulting models are then used to form predictions or make decisions without any need for human input. The last one, and the one that not too many people know about, blockchains and cryptocurrency mining. The act of cryptocurrency mining involves the dedication of system resources to what is referred to as a blockchain, or a continuous record that uses sophisticated encryption algorithms to store transaction data. Each entry in this record is referred to as a block and requires a certain amount of computing power to generate. Some GPU companies: NVIDIA, Intel, AMD, Gigabyte, MSI, and ASUS. Now, this photo shows us some of the GPU challenges: driver issues, overheating, artifacts and glitches, low frame rates, compatibility issues, and power supply problems. Let's talk more about them. GPUs excel at parallel processing, but their individual cores are less powerful than CPU cores for single-threaded tasks, so they are less suitable for tasks that cannot be easily parallelized. One of the most common GPU problems is that it simply doesn't appear to work at all. When a graphics card has some serious problems, it's known as visual artifacts. These can be strange colored squares or lines appearing on the screen, or you could see certain in-game elements flickering, or appearing to display incorrectly, or the entire screen can flicker on and off. The last thing that we're gonna talk in this presentation, now we have this graphic which tells us the effect from Moore's law on the GPUs using in companies. Moore's law is saying that the number of transistors is doubling every 2 years, but with a minimal cost for it for the same microchip. And here we can see that the uses of GPUs is increasing every single year. That's all for today. Goodbye.